Good morning, Tehmina Khan is here in TKMaths is fun. In today's video, we will solve a question on permutation and combination. It's a past paper question. And you know this topic is a part of the syllabus of A-level mathematics S1, right? So first of all, let's see the expansion of NCR and NPR, combination and permutation. You know, combination is when order is not important and permutation is when order is important. These formulas are given to you in MF19 as well. Let's see the relationship between NPR and NCR, combination and permutation. So NPR will be equals to NCR? No, it is not. So how can we make it equal? If we multiply it by R factorial. If you want to see through formula which are given up here, let's write down here. NPR is actually n factorial divided by n minus R factorial, right? And NCR is n factorial divided by n minus R factorial into R factorial. And when we multiply by, R factorial, this will cancel out and now they are equal to each other. Okay, so we will apply this concept in one of the part of the question as well today. So let's see here, find the number of different ways in which the 12 letters of word strawberries can be arranged. Now, strawberries I have written here in this form. It makes me, it helps me to understand better that how many letters are repeated. You can write it in any form you like it. So if there are no restriction when you are arranging 12 letters, so how you can do it? So let's see here. It will be, let me change the color here. So it will be 12 factorial divided by, there are 2s, so they are identical, so 2 factorial. 3 r's are identical, divided by 3 factorial. 2 e's are identical, divided by 2 factorial. So in this way, you can find out in how many ways you can arrange these 12 letters, and answer will be in the calculator. It is 199,584,00. Part 2. If the 4 vowels A, E, E, I must all be together, it means you will make a group of these letters. So let's make it here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so according to question, which letters are together? 2 E's, 1 A and 1 I. Now this is making a group. Whenever there is a group, now this group can be moved anywhere among these 12 letters. So I will consider it as a blank, one blank. The letters are combined here. So now if I see, I have movable blanks are 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so it means 9 factorial. Now in these 9 letters, what are repeated cases? 3 r's, I will write 3 factorial, and 2s, I will write 2 factorial. Now you might be thinking, what about these 2 e's? Here we will deal it separately because this is making a group. So for this group, I will say, okay, 4 factorial divided by, now these 2 e's I will take care here. Now I will calculate and I will get the answer. Right, this is the way you will handle when you are making a group or making 3-4 items together all the time when you are arranging them. So now let's see the part B of the question. 4 astronauts are chosen from a certain number of candidates. They are not telling you how many. If order of choosing is not important, right, initially, which is taken into account, so you're not considering the order. And when the calculation was done, it was noticed that there are 3,876 ways astronaut can be chosen, right? 3,876. Now the part of the question is saying how many ways are there if order of choosing is taken into account. So straight away, when you are not considering order, the way you can choose them are 3,876. But when you are considering order, now how many? So if you remember, I told you just a minute ago in the beginning of the video that NCR, right, is equals to, if you multiply it by R factorial, it will be equals to NPR, right? When order is not important, you multiply by the elements you have taken into consideration, because we are selecting 4 astronauts here. So if you multiply by 4 factorial, it will give you, if it was considered, the order was considered. So I will multiply it by 4 factorial, because this was the number of ways when order was not important. When I will multiply it by 4 factorial, I will get the answer. Let me use the calculator, please. Give me a second. Okay, so 93024. So if order was considered, then those candidates from which I have selected 4 astronauts will be 93,024 ways. Okay, now part 2. 4 astronauts are chosen and they go on a mission. Each of these astronauts can take 3 personal possessions with him. So let me see here 4 astronauts first of all. 1, 2, 3, 4. These are the 4 astronauts, and each one of them can take 3 belonging along. Okay, what they can take? Each one of them can take 3 belonging. Now what it is saying, how many different ways can these 12 possession can be arranged in a row? So number one thing, these 3, they can go anywhere, right? So it will be 3 factorial in any order. Similarly, for this astronaut, 3 factorial. For this astronaut, 3 factorial. And for this astronaut, 3 factorial. Okay. Right now, I'm considering them as a groups. Okay. This is, for example, astronaut A, B, C, D. And each one of them has taken 3 belonging along. So, for each astronaut, if I'm arranging it, it is 3 factorial power 4. Now, these astronauts, themselves it can move. Right now, the belonging of astronaut A is in the beginning, then belonging of B astronaut, then C, and then D. So they can also move anywhere, right? A can come here, C can go here, and so on. So many possibilities. So I will write into 4 factorial for that. Whenever we consider all the possibilities, we multiply it by the factorial. So now this will give me the answer. Let me use the calculator. So 31,104. So I hope you understood this question. You can give your comments, send your comments, and share it with your friends. Please press like and subscribe button. It will help me to, or it will get in, I will get encouragement basically, in short. And you will also get notification when I will upload new questions. So thank you very much. Take care. Bye.